So, Module 5, Part 4, Machine Learning in Operation, still, MLOps. There are many MLOps tools, many tools actually that support fully MLOps or part of the MLOps pipeline. So, for example, there are tools for feature store. For example, there's Feast, which is self-managed tool, but it's very good for feature store. There is Hops Workers. This is also something part of a larger um, tools and platform. There are tools for experimental tracking, like, for example, ML Flow and Clear ML. Also, there is weights and bias. We use some of these tools during this course in the labs. There are classical cloud computing, clustering things for tools for containerization like Docker and Kubernetes, and cloud providers also provide things for containerization like Kubernetes and Docker. Um, Tools for continuous integration, continuous deployment is Jenkins and GitLab, GitHub, and so on. There are tools for monitoring also, like, as we said, Great Expectation is for data validation. Fiddler for monitoring of machine learning models. There are also platforms, as we said, for MLOps, like Amazon Web Service SageMaker, Azure Machine Learning, Google Cloud, and AI platform, and there are many other tools also. So before going to the fully automated pipeline, we talk a little bit also about the maintaining the quality of the data. Maintaining the quality of the data means that focusing on the concept drift and so on, also in the model, in the pipeline. For example, building a classifier that use two input features to separate certain objects into classes. So the thing is that sometimes you can see here monitoring the features also is very important. This is feature one. And so you can see that, for example, this is the decision surface here down with the arrow. And then there is, after some time, there is a concept drift in which the feature is shifting a little bit. So this will cause a lot of problems, and you have to monitor this concept drift. So how we monitor the concept drift, how we find it, it's somehow easy nowadays with all these tools. Do we monitor the features, and if the prediction is not like the ground truth for a certain time, it means that there is a concept drift and there is a shift between the features. Sometimes we call this covariate shift also because the feature are also called covariates in the statistical area. Limitations of covariate shift. Sometimes it's a good indicator of concept drift, but it's not perfect. So sometimes you can see these examples. The top to the left, features and labels at training. You see that this is the training time, but after some time there is the covariate shift without concept drift. The features are changing, however, the distribution itself is the same. So for example, here there is a covariate shift. The distribution is changing, but also the the decision surface is also changing because the uh, the features are changing. Um, so these are examples for this. Also, we are monitoring the output, and how we monitor the output by just statistical distribution. And you compare the statistical distribution of the model. If the distribution is changing, then there is a concept drift. Finally, we will talk about reference architecture. The reference architecture, the big companies actually, they have reference architectures. For example, there's very well-known reference architecture by Google. And this reference architecture is a foundational template, is a template. We say that this is the reference architecture that we follow, and this is the architecture of our system that have MLOps. What the reference architecture gives to the users. So first of all, you have the IT elements. You know where to put the elements in the reference architecture in your organization. IT patterns also, you have the patterns of the IT things that used, for example, in the big companies. And also this reference architecture, you can create your own reference architecture, of course. I mean, you can create your own architecture, but if you depend on some reference architecture, it means that it's just like best practices of coding. So the reference architecture is getting the industry experience. If they do it in Google in this way, it means for a great extent, this has been tested and everything was okay. So this is the reference architecture by Google, for example. This is for fully automated MLOps architecture. You can see that tab to the left, the data is coming, and then you have the experiments. And when you have the experiments, you develop the code. And when you develop the code, you put this code in the repository, which means the Git and GitHub. We go to the right. And then when you have the source code, it means that you build and you have the package, and then you have the pipeline for the deployment. As you remember, we did this before. And then you have the model, you train the model, and then you serve the model, and you have the prediction here, prediction service. However, so this is the continuous delivery or deployment. However, we have the model registry in which we register the model, basically. So this is very important also, because we register the model. If a new model is coming, we register that model also. So we do the archiving. However, we do also the performance monitoring, if you remember, and this performance monitoring is connected to a trigger. For example, if we say that the accuracy came down to less than 95%, so the trigger will be activated. So if the trigger is activated, it means that we go through the automated pipeline now, which means the data extraction, data validation, data preparation, model training again, and we store the data here in the metadata store. And then we evaluate the model and we validate the model. We register the model again, we put the model into production and we serve, and still we monitor it. So you can see that these are the steps. First of all, you get the data. This is basically the offline, let's say, until you do the analysis and everything, and you have the code and you have the source code and so on. So you can see that this whole process can be automated. And if you go for level 3 of MLOps, it means you are going to the fully automated pipeline in which You have a trigger, and the trigger is monitoring something, for example, monitoring concept drift. If the concept drift is happening quite frequent, it means that the trigger will be activated during the performance monitoring, and then it goes through the whole pipeline until the model serving and the prediction service you give it, but still you are monitoring again and again. So this will be an automated pipeline.